thank you very much for your talk. Are there questions from the audience? Yeah, so first of all, welcome and thank you for joining us. Okay, I would have a question. I mean, you just now mentioned that there are probably alternative approaches than the simulated annealing method you use for the optimization. Could you detail a bit what you mean by that? Also, which type of approaches?
Okay, yes. Simulated in a data simulation. At present, we are using simulated annealing, but of course, we can use, for example, genomic algorithm, for example, or particle swarm optimization, or any types of optimization method. So that's another way to do that. Okay. So the point is that we should use the cost function that is a sum of the energy and penalty.
Mm-hmm. I mean, when you assemble this cost function out of these two things, also energy and the data, wouldn't it be an option to use a multi-objective optimization to satisfy both terms of your cost function individually?
Yes, yes, we can optimize each function individually. Yes, in our optimization method. That is one way. Yes, yes, we can do that.
Okay, I think Martin has a question in the Q&A.
Yeah, so I have a question from the Q&A panel. It reads, as I understood, the simulation is biased by system-specific additional potential. Once the crystal structure is read, what happens if this bias is removed?
Yeah, right. Yes, exactly. So we use the cost function, the sum of the total energy, potential energy, and penalty function, and optimize the structure. And after that, we remove the cost penalty function. Mm-hmm. If the structure is not stable, the structure changes. So we can know that the structure is physically reasonable or not.
Now, but if you have these, let's say, incomplete and noisy data, and you would have two minima which are kind of close by in energy. So, I mean, if it's a bit of you are close to a phase transition or something, what would happen? How can you deal with this problem? Especially if you have data which are not so rigorous or clear.
Okay, if the data, we have various experiences. For example, if the data is very noisy and we cannot observe small peaks, then we sometimes get, for example, a high temperature phase of the material, for example. So you have to be very careful about how to treat the noise and how to pick up the peaks. Yeah. So, and if there are many metastable structures, the structure prediction becomes more and more difficult.
So in this sense, if you would try to develop a user package who plugs his data in,
sure, yes,
and which is kind of automized, this is something dangerous also.
Yeah.
Yes. So, so in the end, it also means that the quality of the energy function, for example, the DFT method you use, has also a big impact on your judgment of the result. So, as you said, I mean, if the experimental data forces essentially the simulation to a certain structure, if you remove the experimental bias, you lose this structure again. This can certainly also be a fault of the energy function, right?
Yes, I'm afraid I cannot catch what the point, but yes, you're right. Yeah. So,
no, I mean, do you also try alternative potential energy functions to use in your setup?
What do you mean? The alternative potential energy?
Yeah, I mean, you have some DFT attached to it, right?
Okay. So we are testing using we are using DFT functional or sometimes in model potentials that is accurate enough. And of course, we can use neural network potential if you like. We are now doing that.
Okay.
So, so because we know that we have some information from experiment, so the interatomic model potential should not. It's not so. Can be not inaccurate. I mean, it's a potential model is not so accurate. It sometimes works because you know the experimental data. That's a very interesting point. So usually it's difficult to make a very good neural network potential, but we can use inaccurate neural network potential in some cases. So
okay.
it can reduce the computational cost. Yeah.
On what type of data are you training your network?
So we first perform first principles molecular dynamics at high temperature.
Okay.
Yeah.
Thank you. Are there further questions also from the audience? No. So I again just wanted to encourage you, also the participants, to raise your hands, also to have personal questions during the discussion section. Yeah. So I think in that sense we would now essentially proceed to the next talk. Thank you very much for joining us for this conference and for the discussion here.